Hello, good afternoon, everyone. A very warm welcome to the GATE Academy, to the part 2 of Irrigation and Hydrology GATE Score Booster session. So I hope you have already seen the part 1 of this particular subject. If not, the video will be available in our channel. Please go and watch it. The initial portion of hydrology, which are the precipitation, evaporation and infiltration, those portions which we have already completed in the first part. A part of infiltration we will discuss in this session also. Then from hydrograph onwards, we will start and we will finish the irrigation portion also in this particular video. Okay. So in the first part, we have taken some more time because basics has to be thorough. If you are having the basics, then whatever questions they are going to ask, whatever tricky questions they are going to ask, you can easily solve. Okay. The foundation is more important for us. Okay. So please let me know who all are there so that we can start the session without wasting much time. Devi, good afternoon. Krishna, Ahmad, good afternoon, everyone. So where we have ended in the first part is, I think, in this infiltration, right? We have calculated the runoff using Horton's infiltration curve. So I hope you have gone through those questions. Those who missed the first part also, I hope you know this concept. So what is actually happening? The rate of infiltration keeps on decreases exponentially. You know? So Horton has given one equation also for that exponential decrement in the rate of infiltration. So what we are actually doing for simplicity in calculation and analysis, instead of taking this exponential reduction in the rate of infiltration, we are assuming one average value of infiltration. You know? So that is nothing but our infiltration indices. We have two infiltration indices, phi index as well as W index. So this question is related to the infiltration indices. So just go through the question and try to solve it. So I'm giving some few time to you. Okay, few seconds I'm allotting to you to check the question and take the data, start solving it. So once you are trying it, I will start explaining it. Okay. So Gursa just joined. Sam Koshi, good afternoon, everyone. Sorry if I'm missing any name. So try to solve it. Please let me know if you have any problem with the font size and all. Yes, I hope you have taken down the data. Data is nothing, where only few values we have to note down. Very index, phi index calculation is very easy. Are you getting the answer by this time? 30 seconds is enough actually to calculate the phi index. Yes. Meanwhile, you are solving, I will just give some introduction. So what is phi index? Basically, we have two indices, W index and phi index, right? So what is W index? The depth of precipitation minus the runoff value, which gives us the depth of infiltration. And we know that this is nothing but rate of infiltration, average rate of infiltration. So the depth of infiltration divided by time gives the W index. Now what is the difference between this W index and phi index? Nothing but we are not going to select the entire P value. We'll only select those precipitations which are producing the runoff. You know? So we know in the last session, in the part 1, we also discussed the synonyms of runoff: effective rainfall, useful rainfall, then excess rainfall, etc. So that effective rainfall we are giving E. This stands for those rainfall which are producing the effective rainfall, means those rainfall which are producing the runoff value. So PE minus R divided by TE, the corresponding time of that PE, is nothing but the phi index. Okay. So this is the equation. If it is a uniform rainfall, means throughout, if the intensity is constant, then both phi index and W index will be same. Directly we can calculate the value, but whenever the rainfall is non-uniform, that is the intensity keep on changes, we have to do some changes to calculate phi index, right? So hi VC, Ram, Kushbu, good afternoon everyone. Anyone who is getting the answer? Yes, very good. What is the answer you are getting? Few students are making mistake also. See, that's why I told you have to properly listen to the question, properly read the question and understand whether the rainfall is uniform or not. If it is a uniform rainfall, then directly we can calculate. Whenever they are giving non-uniform rainfall, what is the meaning? See, in the first hour, not in the first hour, they have given in 30 minutes interval. So it keeps on changes, 6, 13, 26, like that, it keep on changes, which means we have a non-uniform rainfall. The intensity of rainfall keep on changes. So whenever this intensity of rainfall keep on changes, our first step is to calculate the W index. They are asking us to calculate the phi index only, but first step is to calculate the W index. Okay, so how can we calculate the W index? Just take the p-value. How can we take the p-value? Intensity into time. We have already seen in the previous session. So 6 mm per hour multiply with 30 minutes. So 30 minutes means 0.5 hour. So 6 into 0.5 plus the next intensity is 13, 26 and so on. So 13 into 0.5 plus 26 into 0.5. See, you can simply take 6 plus 13 plus 26 plus 14 plus 9 plus 3. Then you can just take the 0.5 outside. So simply for your understanding, I'm just writing everything. We have 3 also. That's it. So 1, 2, 3, 4, 5, 6. What is the total time? That is more important. Whenever they are not giving in terms of 1 hour, it is given at is 30 minutes. So properly listen. What we need to substitute then? The time will be 3 hours. Okay, not 6 hours. Time will be 3 hours. So what is the runoff value given in the question? We can just directly substitute that value. Given that it is 8 millimeters. So tell me how much is W index, everyone? How much you are getting W index? So the value you are getting 35.5 minus 8, right? Yes, thank you. 35.5 minus 8 divided by 3. Yes, thanks for commenting. 9.166 mm per hour, right? Yes, thank you. So can I select option B? Can I select option B? Obviously no, because they are asking phi index. If it was a uniform rainfall, then all these intensities will be same. Throughout it may be 6, 6, 6, 6 like that, or 13, 13 like that. Then both phi index and W index will be same. But whenever non-uniform rainfall is happening, what is our step 2 then? We have to select those intensities which are greater than W index. Very important. Properly listen. I'm not telling greater than or equal to. I'm telling simply greater than. In the sense, if you're having same value, suppose we got 9.166. If you have the same intensity in the question, 9.1 like that, then we will not take it. We'll take exactly greater than W index. So which are those intensities? 6 we are eliminating. 13 we are going to select, obviously. 26. 14, that's it now. So 9 is obviously less than 9.1. So this also we are eliminating. Okay, is it clear? Yes. So what we have to do now? We'll select those intensities which are perfectly greater than W. So which all intensities are remaining now? So 13, now 26, now 14. Only 3 intensities are greater. Okay. No, runoff remains the same, 8 millimeters. Now tell me what is this denominator. Everyone please comment. How much will be this denominator? Will it be 3? Obviously no. Yes, very good. 1.5. Very good. Because whatever time we are taking in the numerator. Okay, only these 3 intensities are going to create runoff. So correspondingly 0.5, 0.5, 0.5. Why this is 0.5? If anyone is having doubt, they have given 30 minutes. We are going to convert into hour, okay? And why we are converting into hour? We know precipitation is equal to intensity into time. They have given all the intensity values in mm per hour. So if we want to get the depth term, we should substitute the time value in hour. Then only hour and hour will cancels. We will be getting in millimeter. Yes, very good. So 1.5 will come here. Tell me what is the answer? Yes. Yes, very good. Very good. Kasturi Das, Kushbu, very good. Tripti. Yes. So what's you are getting finally the answer? 12.33 mm per hour. Yes, very good. Are you getting the answer, everyone? Is it 12.66 or 33? Everyone please comment. I'm getting a comment 12.66 also. Yes, 33 na? Kushbu, check your calculation. Yes, so according to the options, which is our right answer? Yes, option C will be the, are you getting 12.6? Is it? Okay, then I might have made some mistake. Is it 12.3 or 12.6? 12.33, right? Yes, 26.5. You know? So this is going to be 26.5 minus 8 divided by 1.5. I hope I didn't make any mistake. Okay, thank you. Okay, getting option C as the right answer. That's it. Okay, so always check whenever they are asking phi index, check whether it is a uniform rainfall or non-uniform rainfall. Uniform means throughout the same value, and very importantly, such different duration also you have to check. By mistake, don't put 1 instead of 0.5. That's it. Clear? Sometimes they will simply give you one intensity. For example, if they are giving a 3-hour rainfall having an intensity of 5 mm per hour, like that, only one intensity they are giving in the question, then we are understanding from the data that it is a uniform rainfall. They may not mention in the question that it is uniform, it is non-uniform, like that. Okay, yes, very good. All are getting the answer. Yes, that's it. Understood infiltration? That's it. So Horton's infiltration curve, then this infiltration index, then the calculation of runoff using Horton's curve and phi index. These things you have to properly remember. Is it clear? Yes. So simply, if they are asking you what is the effective rainfall intensity, that is another point. We know what is effective rainfall. If they are asking you what is the effective rainfall intensity, we know intensity of rainfall is I and the rate of infiltration is phi. So the runoff intensity, we can also write it as I minus phi. Understanding? Or the runoff value, we can also write it as I minus phi into time. Understanding? This is nothing but actually our phi index. You see, R is equal to IT minus phi into T. So what is this I into T? Precipitation. So P minus phi into T. So what you are getting, phi is equal to P minus R divided by T. Okay, phi or W, whatever. Okay, for a uniform rainfall. Okay, so this point also you can simply keep in mind. Maybe if they are asking which of the following relationship is true, if they are asking effective rainfall intensity is equal to I minus phi, you can select it. Clear? Yes, very good. So we are moving into the next chapter then, hydrograph, one of the most important chapter we have. So just go through the question and understand. Everyone please go through the question and understand what we have to do. A 2-hour unit hydrograph is given in 1 hour intervals, right? A 2-hour unit hydrograph for a catchment respectively at 1 hour intervals. Okay, we have to find the catchment area. Very important equation for hydrograph. The runoff depth is equal to runoff volume divided by area of catchment, and that area of catchment they are asking how to calculate the area of catchment. Yes, very good. I'm getting the answer already. Very good. Now see, I'm just telling you some points. We know if you want to calculate the runoff depth, then Runoff depth is equal to runoff volume divided by area of the catchment. Meter cube per meter square is equal to meter. Like that we are going to get. Now, whenever they are giving the ordinates, whether it is a unit hydrograph or it is a direct runoff hydrograph or flood hydrograph, whatever, this is how we are going to calculate the area under the curve. Okay, whenever they are giving irregular shape, using the trapezoidal method, we are using the trapezoidal method, we are going to calculate like this. If I am simply putting O1 to O9, just for an example, okay, not for this particular question, how we are going to calculate in general. Okay, first you look at the second figure. If they are giving different time interval, means this is lesser T1 and the second ordinate, second time interval is T2, then T3, like that, different time interval. Not exactly 1 hour, 1 hour, 1 hour. It may be 1 hour, then 2 hour, then again 1 hour, then 3 hours, like that if they are giving. This is how you have to calculate the area under the curve. So area under a DRH or unit hydrograph or whatever is nothing but our runoff volume. Runoff volume is equal to area under the hydrograph. It is not area of catchment, area under this figure, that's it. And area under this figure is magnitude is equal to the runoff volume. Okay. Now how we are going to calculate it? The average of the adjacent ordinates, O1 will come here only. The average of the adjacent ordinates multiply with the corresponding time interval. Okay. If you are remembering only this equation is sufficient. Now, if all these T1, T2, T3, etc. are equal, this delta T are equal, we will be getting this first equation. First ordinate plus last ordinate by 2 plus then sum of the remaining ordinates. You can just check it. Okay. If you are putting all the delta T, delta T, delta T like that, you will be getting this equation. Whenever we are coming to unit hydrograph or direct runoff hydrograph, we know the first and last ordinates will be 0. So this shape we are going to get for a flood hydrograph only. For unit hydrograph as well as for direct runoff hydrograph, the first and last ordinates will be 0. So this portion will be eliminated. So if it is a unit hydrograph or direct runoff hydrograph, we can directly take runoff volume is equal to the sum of the ordinates multiply with the time interval. Okay. Now coming back to the question, they have given everything. It is in 1 hour interval, which means delta T is same everywhere 1 hour. So directly we can take the sum. The runoff volume will be 0 plus, no need to take first and last 0, 7 plus 12 plus 7 plus 4 plus 2, like that we can take. So I'm writing the equation. The runoff depth is equal to, everyone please comment how much you are getting now. You might be already getting it. So 7 plus 12 plus 7 plus. Please calculate and tell me how much you are getting. Now see, very important one thing. All these things are in meter cube per second. This is another point students used to make mistake. Now we have 1 hour here. What we have to do? We have to convert into seconds. Okay, multiplying with 3600 or 60 into 60. Then only we are going to get it in meter cube. Now we have to divide that with area of the catchment. Right? Now whatever we are getting here, area of catchment, the unit will depends on the left hand side unit. So what we need to do, it's a unit hydrograph, very important. For a unit hydrograph, runoff depth is equal to 1 centimeter. That itself can be a gate question. Okay, so which means 0.01, sorry, which we have to substitute 0.01 meters. Okay, then only meter cube and meter will get cancelled, and we are going to get the area of catchment in meter square. Okay, right. So tell me, Monsieur, please, you just go through this session, first part and second part, rather than skipping the subject that I told already in the first part. Don't simply skip it. You just watch this session and the previous session 1 also. I have just discussed the basics also, concept also. That's it. Okay, will be sufficient for your preparation. Don't skip the subject. Guys, please tell me what is the answer that you are getting. Everyone, let me check my calculation also. Yes, are you getting 11 point? Sorry, I missed my calculation somewhere. Yes, okay. Are you getting 11.52 into 10 raised to 6? Yes, thank you. So 11.52 into 10 raised to 6 meters square. So we know 1 kilometer square is equal to 10 raised to 6 meters square. Enough? 10 raised to 3 into 10 raised to 3. So that is going to be, that's it. Right? So what is the answer of the first part? Yes, very good. Since all are commenting, no need to explain again, I guess. Right? Yes, thanks for commenting. Now, what about the second question? The peak discharge of the 3-hour unit hydrograph. How can we calculate the peak discharge of a 3-hour unit hydrograph? Listen always. If you have a particular value d-hour unit hydrograph, and if they are asking us what is the peak or what is the ordinate of a d-hour direct runoff hydrograph, or what is the ordinate of a d-hour flood hydrograph, then what we can do? We can just multiply with the runoff value, which is in centimeter. And if we are having a d-hour unit hydrograph, if they are asking a different duration, they can ask a different duration unit hydrograph. They can ask a different duration DRH, direct runoff hydrograph. Similarly, they can ask a T-hour flood hydrograph also. Okay, then we cannot use this multiplying with runoff. This is absolutely wrong. For this, we have to use either method of superposition. We have to use method of superposition, or we have to use S-curve method. Okay, so how we are going to decide a method of superposition and S-curve in detail, I have explained in the last year video, which I have already told you. You can just watch that for more explanation. So some basic I'm telling, what is that? If you have a particular hour unit hydrograph, for example, in this question they have given, it is a 2-hour unit hydrograph, and a 2-hour unit hydrograph. So if you have a 2-hour unit hydrograph, if you are multiplying with the runoff value, you will directly get the ordinates of a d-hour DRH or a d-hour flood hydrograph. Okay, since I am getting repeat and all, okay, simply I am taking an example. In this question, we have a 2-hour unit hydrograph. Enough? If they are asking the ordinates of a 2-hour DRH, direct runoff hydrograph, or if they are asking a 2-hour flood hydrograph, what we can do? We can simply multiply with the runoff value for each ordinate. In the sense, if they are asking, see all the ordinates we have now, 0, 7, 12, 7 and all. If they are asking us what is the ordinates of a 2-hour, this one. We have 2-hour unit hydrograph ordinates with us. If they are asking what is the 2-hour DRH, direct runoff hydrograph, with a particular runoff value, maybe 10 centimeter, then what how we can calculate this ordinate? 0 into 10, 0, 7 into 10, 70, 12 into 10, 120. Like that, we can calculate ordinate of a 2-hour direct runoff hydrograph. Understood? We can simply multiply each ordinate with the runoff value to obtain the same duration, 2-hour DRH. Now understood, everyone? But here we have a 2-hour unit hydrograph. They are asking what is a 3-hour DRH, or if they are asking what is a 4-hour DRH. Okay, like that, something different duration if they are asking, then we cannot do this step. Now is it clear, everyone? Those who told to repeat, now is it clear? Okay, runoff value, and I will tell. Please wait till here it is clear. If they are asking the same duration, then we can simply multiply with the runoff. Runoff we are going to calculate and all, I will tell you. Okay, is this clear now, everyone? Yes, very good. Now, whenever they are giving like this different duration, what we need to do? Either we can go with method of superposition. See, now listen here what I have written. We have D. If they are asking this, generally we use we can simply put T1, T2. Okay, generally in hydrology, we use the letters D and T. That's why I have written here. Okay, yes. Similarly, if they are asking some other duration, then they can ask another duration unit hydrograph also. Then we cannot multiply with runoff. We have to go with either method of superposition or S-curve method. How we are going to decide that? Whatever we want is capital T. What we have is D. So we'll take a T by D ratio. We'll check what is the T by D ratio. For according to our example, what we have is in the data, what we have is a 2 hour, which is D. And what we want to calculate is some ordinate, peak ordinate of a 3 hour. So what we want to calculate is 3 hour. What we have in the question is 2 hour. So what we want to calculate is T is 3 hour. What we have is 2 hour. 3 by 2, not 2 by 3, 3 by 2. What we want divided by what we have in the question. Is it clear, Srikanth? It's not 2 by 3, 3 by 2. Okay. So how much is 3 by 2? Is it an integer? No, it is 1.5. It is not an integer. If it was 4 by 2 and all, then we will be getting an integer too. If we are getting an integer, then we can go for method of superposition. Or we can use S-curve also, but whenever we are getting some decimals like this, we have to go for only S-curve method. Understood? Whenever we are getting some decimals, we can go only for S-curve method. For example, another example I'm telling, if we have 2 hour unit hydrograph, like this question, and if they are asking you what is the ordinates of a 4 hour unit hydrograph, or if they are asking what is a 4 hour DRH, or if they are asking what is a 4 hour flood hydrograph and all, if they are asking, I will explain this flood hydrograph after some time. Then if you are calculating, what we want to calculate is T, which is equal to 4. What we have is D, which is 2. We are getting an integer. Then which method I can use? Either I can use the first method, superposition method, or we can use the S-curve method. Okay, both are going to be giving you the same answer, but method of superposition is comparatively simple method. So better if they are asking. So if they are asking the question and you are getting an integer, better you use method of superposition in the examination. Okay, S-curve is comparatively complex, but I'm going to make it simple. Don't worry. Okay. So in this question, now you tell me which method you are going to use. What we want to calculate here, I'm just going back to the question. What we have in the question is a 2 hour unit hydrograph. And what they are asking is a 3 hour unit hydrograph peak value or ordinate value. Which method you are going to use? Which method you are going to use? Everyone please comment. Everyone please comment. Very good. 3 by 2, 1.5. We can use the S-curve method only. Understood now? Clear? Yes. Now see, what do you mean by this peak discharge? What is the peak discharge of this unit hydrograph? According to this question, what is the peak discharge? 12 meter cube per second. According to this one, so it keep on increases, then decreases. This value is 12. Every time doesn't, every time it will not increase and decrease. Sometimes it may keep on increase, then constant, then decrease, or it may come down and again go up. It depends. Okay, it depends on the catchment and intensity of rainfall and all. Okay. Now here we are getting 12. Okay, peak of a 2 hour unit hydrograph. Now they are asking what is the peak of a 3 hour unit hydrograph. So what is the step of S-curve? So what we need to do now? We have to check how to do the S-curve method. So I'm just taking, one second. I'm just taking an image for writing everything. 1 second. Yes. So in the paper which you are going to get it in the examination hall, what you have to do, you just write horizontally using some arrow marks. Okay, just for showing you, and it's difficult to write it on the screen properly. That's why I'm just taking a table here. So the first column will be time. The second column will be our 2 hour unit hydrograph. Nothing but according to this question, 2 hour unit hydrograph. So this is what we have as of now. In S-curve method, what we have to study, the first table is addition table. Nothing but we are going to add some elements to this D hour unit hydrograph. What are those elements? The first addition value will be always 0, and that will start at time t is equal to D hour. Remember, the first addition will be 0 and it will start at the time equal to D, which means where is our D here? What is the value of D here? 2. So what is that time 2? Here. So corresponding to this, our first addition 0. Is it clear now? Till here it is clear, everyone? Okay, properly follow me, otherwise later it is difficult to come back and explain it again. Yes, clear now? The first ordinate will be always, first addition will be always 0. That will start at D. See, actual conventional method is lengthy. This is actually a shortcut. Okay, actual conventional method is lengthy and time consuming. This is a shortcut. So properly remember, this is 0 we got. Now see, the first addition is 0, which means here we don't have any addition, nothing. Now what is this SA column? Nothing but our D hour unit hydrograph plus the addition column. So if you are adding, what we will be getting? 0 plus nothing is equal to 0. 7 plus nothing is equal to 7. 12 plus 0 is equal to 12. Understood? Till here, is it clear, everyone? We are simply adding the unit hydrograph table plus addition table. We are going to get our SA column. Okay, as of now, simply take it SA. That is it. Summation curve. Okay, S stands for summation curve. Summation, we are adding it. Okay. Now remember, your addition column and SA column and SB column, all these three columns will be same. Same elements will be there in all these three columns. Only thing is they will change their location. That's all. Means now we got 0, 7 and 12. Three elements we got it in the SA column. Now 3 elements we got it in the SA column. Now what we can do now? I told you same elements will be there in addition column, SA column, SB column. Now what will be the second ordinate here then? Please tell me. Yes. Now we got 2 more elements here, 7 and 12. Okay, because they are going to be same. And now it will be a cyclic process. What is that cyclic process? We got 2 more elements in the addition column. Now we can do the same procedure. 7 plus 7 will be equal to, so if anyone is getting doubt, I can write 7 plus 7 is equal to 14, right? Then 4 plus 12 is equal to 16. So we got 2 extra elements in SA column. Now we know both columns should be same. So 2 more elements we are getting here. It's keep on, it will be a cyclic process. So 2 here, 14 here. So we can put 16, then 0, 16, 16. See, we got 2 more elements in the SA column, 16, 16 and all. So it keep on continues 16, 16, 16 like that it will go. Understood till here? Okay, till here it is understood. Now coming to SB, I told you addition column, SA column, SB column. All the elements will be same. Only thing is addition will start at D and it is starting at time equal to 0, and SB will start at time is equal to T hour. Understood? Okay, so what will be the elements? What will be the elements under SB? We got the elements in addition column and SA column. So go to the SB column and just fill and start at time equal to T. So what are this? What is the value of T, capital T? So this is nothing but our capital T, nothing but 3. So just go and fill it. So where it is? So corresponds to the time 3, we are going to start 0. Then we have 7, we have 12, we have 14, 16, 16 onwards. Understanding, everyone? Now, according to this columns, what we can do? Simply take the difference SA minus SB. So here we have nothing, 0, 7, 12, 14. Just fill it and tell me what is the peak value you are getting. Yes, please comment everyone. Yes, very good. So here we will be getting 9 and 2. Sorry, here we'll be getting 4. Anna, are you getting the same answer? Yes, very good. I'm already getting the answer. So SA minus SB will be 0, 7, 12, 14 and so on. Right? Yes. So, see, no need to calculate SA minus SB divided by T by D. We just have to check which is the peak value of SA minus SB. Okay. If you are having this peak value of SA minus SB, directly you can take that peak value and save your time. No need to calculate everything. So 14 divided by 1.5. How much you are getting 14 divided by 1.5? Everyone please comment. Yes, very good. Thank you for commenting. 9.33. Correct? All are getting? Yes. So actually what is this SA minus SB? It actually stands for our T hour direct runoff hydrograph. It actually stands for the T hour direct runoff hydrograph with the runoff value is equal to T by D. Understood? This SA minus SB actually stands for a T hour DRH with runoff value is equal to T by D. Now this will stands for the T hour unit hydrograph. Understood? So that's why we have divided with capital T by D ratio, and this is how we are getting the unit hydrograph. Understood? Everyone? Yes. So are you getting 9.33 as the answer? Is it clear, everyone? Please comment, is it clear or not? Sangeet, first you just listen the complete video. Otherwise, how can I tell you whether you will able to solve or not? Okay, please just watch the entire video and you just analyze yourself whether you are understanding everything. Okay, is it clear? Yes, very good. So what will be the answer of the second question? So it is round off to integer. So 9.33, either you can put it as 9 or you can put it as 10. So if they are asking, they may ask round off to 1 decimal and not. Okay, so either 9 or 10. Clear, everyone? Yes. So understood S-curve method? Okay, that's it. So the next question we are going, which is somewhat another level of question. Just go through the question and understand what we need to do. Go through the question and understand what we have to do, everyone. It's a complex rainfall and we have to calculate what will be the peak of the resulting direct runoff hydrograph. Recent gate question is also there like this. Take down the data first, then I will just give an explanation. Yes, very good. I hope all are following. Yes, very good. Have you taken down the data and understood what is the change in this question? They have given a 2-hour unit hydrograph and different runoff values also given. For first 2 hours, we have 2 centimeter runoff. For the next 2 hours, we have 1 centimeter runoff. For the next 2 hours, we have 0 centimeter. No runoff has been produced. For the last 2 hours, we have 1.5 centimeter runoff. Now, whenever you are having this much like this data, for a same duration, we have different runoff value. Then what we have to do to calculate, see, for each of these 2 hours, we can calculate separate. See, as the runoff value decreases, as the runoff values changes, different DRH we will be getting. We can find a 2-hour DRH here. We can find another 2-hour DRH here. We can find another 2-hour DRH for the third one. And the last is another 2-hour DRH. What is the difference between all these 4 different DRH? All are having different runoff. The first one is having 2 centimeter, next one 1 centimeter, and so on. Now see, if I am adding this 2-hour DRH plus 2-hour DRH plus 2-hour plus 2-hour, will we be getting 8-hour DRH? Is it possible? If you are adding, see, method of superposition, what actually we are doing, if we have a 2-hour unit hydrograph, for example, if you are adding it with another 2-hour unit hydrograph, if you are again adding it with another 2-hour unit hydrograph, combinedly we are going to get a 6-hour direct runoff hydrograph, because 1 centimeter runoff, 1 centimeter runoff, 1 centimeter runoff. Runoff will be 1 plus 1 plus 1, 3 centimeter. Similarly, if we are adding 4 number of 2-hour DRH, what we'll be getting? We'll be getting an 8-hour DRH with a runoff value 2 plus 1, 3 plus 4.5, like this. Yes, very good. So if we are able to obtain a 2-hour DRH like this, then can we add all those 4 DRH and find what will be the resulting direct runoff hydrograph? Is it possible? Yes. But how will we getting this 2-hour DRH? We can find this 2-hour DRH from the 2-hour unit hydrograph. That's what they have given in the question. A 2-hour unit hydrograph is given. Now you please comment, if we have a 2-hour unit hydrograph, and if I want a 2-hour direct runoff hydrograph, then maybe for the first one, if I want to calculate this first one, I know the corresponding runoff is 2 centimeter. Now, can I do this calculation? If I'm multiplying with 2, will I get this? So everyone please comment, yes or no. Can I do this, or should I use method of superposition or S-curve method? Can I use this, yes or no? So your reply will make me understand whether you have understood the previous question or not. Can I do this or not? 2-hour unit hydrograph, if I am multiplying with the runoff value, will I get 2-hour DRH or not? Everyone please comment. Very good. Absolutely yes. Enough. Why? Because duration is same. That's it. As simple as that. If it was 3-hour or 4-hour, then we cannot use. Here the duration is same. Duration is same, so we can easily multiply. If I want 2-hour DRH, I'm not asking 8-hour DRH, I'm asking you 2-hour DRH. Okay, my question is not 8-hour, 2-hour. Okay, is it clear now? Now how can I calculate the first 2-hour DRH? We have the ordinates with us, 0, 10, 20, 48 and all. We just have to multiply each ordinate with 2. Then we'll be getting the first 2-hour DRH. Then the second 2-hour DRH we'll be getting if we are multiplying with the second runoff 1 centimeter. Third one, every ordinate will become 0 since it is 0 centimeter. Fourth one, 1.5 centimeter. Enough? So you do it. But whenever we are adding it, what we have to note down? Let me take one figure to make you understand. Yes. So once you are doing it, you can just do it yourself. Just to save time, I have just shown like this. So what we have, these are the unit hydrograph ordinates, and the first DRH will be nothing but all these values multiply with the runoff value 2 in centimeter. So we will be getting the ordinates like this. Whenever we are putting the values of the next unit direct runoff hydrograph, similar to method of superposition, we have to shift by d hour, d hour delayed. It is similar to method of superposition, but instead of unit hydrograph, we are taking DRH because runoff is not 1 centimeter. That's all. Okay. DRH is actually sorry, unit hydrograph is actually a kind of DRH with runoff 1 centimeter. So this is 2 times D hour delayed. So this is 3 times D hour delayed. Are you understanding? Are you getting the same data? Just to save time, I have just shown that. Is it clear, everyone? Please comment. Is it clear, everyone? Please comment. Yes or no? Yes, very good. So the resulting DRH will be having a runoff value which is equal to 2 centimeter here, 1 centimeter here, 0 here, 1.5 here. It will be having a runoff of 4.5. Okay, we don't require that. What they are asking is the peak of the resulting DRH. Okay, only thing is properly multiply, and if they are giving 0, simply don't skip it. Okay, if they are giving 0, take it. Okay, otherwise you may make mistake here, or you can simply directly take this this one, but you have to shift by 2 times. Okay, those things you just remember. Discharge or peak value of the resulting direct runoff hydrograph. Are you getting the answer, everyone? Is it clear? Yes, very good. Now see, either they can give like this directly. The runoff is equal to 2 centimeter, runoff equal to 1 centimeter. Then the last one is 1.5 centimeter. Okay. The same thing they can also give, like instead of giving you directly the value of runoff, they can give the effective rainfall intensity. What do you mean by effective rainfall? Runoff. Can you tell me what is the effective rainfall intensity in this 2 hour? Everyone please comment. If you are solving this table, just leave it. You can just take down later. What will be the effective rainfall intensity in the first 2 hour? Everyone please comment. Very good. 1 centimeter per hour. 2 centimeter divided by 2 hour. That's it. Then the second one, effective rainfall intensity is equal to 1 centimeter by 2 hour, 0.5 centimeter per hour. Here it will be 0 centimeter per hour. Here it will be 0.75 centimeter per hour. Effective rainfall intensity. So like this also they can give. This is what they have given in the GATE question recently. Either they can directly give the runoff or they can give the effective rainfall intensity. Then we have to correspondingly have to multiply with the time, then take the runoff value. Is it clear? By mistake, don't multiply with the intensity value. Okay, by mistake, don't take 1.5, 0.75 and all. Convert that into corresponding runoff depth by multiplying that D hour. Is it clear? Everyone, is it clear? Yes, I have taken a separate question in the gate booster session, which we have done the last year. I will comment the link. Okay, once this video is uploaded, we'll comment the link of the last year video. There also you can just watch it. Concepts will be same, but different problems you can just try to solve. Clear? So hydrograph is okay now? Yes. So those two are the important portion in hydrograph. Now see, one more thing I can tell you. In case if they are asking, or in case in the question they are giving us that it is having a base flow. Okay, maybe generally in such a question they may not be asking. This question also they can ask, no problem. Maybe in the last question if I'm taking, and we got the peak of, see here what is the peak of the 3 hour DRH? We got 14. If you are getting some peak of DRH, okay, if you are getting a peak of 3 hour DRH is equal to 14 meter cube per second. If they are giving in the question that base flow is equal to maybe, for example, 5 meter cube per second. Okay, base flow means the value which is already present there even before the rainfall. Okay, maybe in a stream there is already some water flowing. No? That's it. Now if they are asking the same thing, what is the peak of a flood hydrograph, then what will be the value? Yes, very good. This peak of the DRH plus base flow. Okay, so that will be equal to 19. This is not for the previous question. This is another example. Okay, extra point. If they are asking what is the peak of the resulting storm, flood hydrograph is also known as storm hydrograph, okay, or total runoff hydrograph. DRH is direct runoff hydrograph. Total runoff hydrograph means flood hydrograph. Total runoff means direct runoff plus base flow. Okay, or if they are asking what is the peak of the hydrograph as a result of the storm, okay, then which means we have to add the base flow. If they are not giving the base flow in the question and asking flood hydrograph, which means base flow is 0, we will assume base flow is equal to 0. Understood? Then DRH and flood hydrograph are same. Clear now? Concept of flood hydrograph. Similarly, we can go back also. If they are giving us the peak of flood hydrograph is 19, and if they are asking you what is the ordinate of the peak of the 3-hour unit hydrograph, then what we can do, just minus that base flow, we'll get the direct runoff hydrograph divided with the corresponding runoff, we'll be getting unit hydrograph. Is it clear? Clear everyone? Hydrograph? Yes. That's it. Now going into the next question, which is related to aquifer. So just go through the question. Just go through the question. Yes, one extra point I'm telling since I got a doubt. If you are drawing the flood hydrograph, see how much base width will be there. Base width means from the starting to ending, that one, okay? So how much base width will be there, that depends on the catchment properties and all. So if we have an urban catchment, means town area, and if we are comparing with the rural catchment, village area, in village areas, we may be having so much of vegetation and all. You know? So these trees and plants will try to resist the runoff. So this runoff will come to the outlet very slowly only. So if it is a village area, means rural area, your runoff will be having, or your hydrograph will be having more base width. This is not for this particular question. And if it is a town area, or I can tell urban area, then we will not be having that much vegetation, and we may be having proper drainages and all in town areas. So fast we will be getting the discharge. So high discharge will be getting in faster duration. Okay. So in a urban area, in an urban area, we'll be having high peak value with lesser base period. In a rural area or village area, we'll be having lesser peak value and more base width. Okay, this is an extra point I told, not related to this question. Clear? Yes. They are the topics which can ask for 1 mark, like or in MSQs type of question. Which of the following statements are true? So I hope you have gone through the question and take down the data. So first of all, tell me whether this aquifer is, it's a confined aquifer or unconfined aquifer. Tell me whether it is a confined aquifer or unconfined aquifer. Yes, very good. It is an unconfined aquifer, because they have, from the question itself, it is clear. If it is a confined aquifer, then properly there will be 2 impermeable layers. Impermeable layers will be there. Then in between the impermeable layers, we will be having the aquifer. In this question, you properly listen. There is a sand stratum of 45. There is a sand stratum of 45 meter thickness. We are inserting a clay layer of 2 centimeter thickness is present below this layer. So I'm not drawing on the scale, simply 2 meter clay is present here. Purposefully, I have given that sentence just to make you deviate. This aquifer will be a confined aquifer if and only if there is another clay layer here. Is it having another clay layer here? Is it having another clay layer here or only below? Now tell me. Very good. Which means it is having only clay layer, impermeable layer below. It is not having anything above, which means it is an unconfined. It is not confined. What do you mean by confined? Sandwiched in between two impermeable layer. Okay, so it is free to the free ground, okay, atmosphere. So it is an unconfined aquifer. Okay, properly understand that from the question. Sometimes they will directly give, sometimes they will not give. That's why I have not given. Even if they are not giving, you shouldn't lose your mark. You should understand from the question. Clear? So these sentences are giving to deviative. Okay, they are giving thickness, clay layer and all. If it is above also, then it is confined. Before going into the question, I'm just giving an introduction. Whenever we are taking the water out or pumping out the water from an aquifer or a pumping well, this is nothing but our aquifer. Okay, the water table will get decreased and it will take a conical shape. We call it as cone of depression. Now, if you know what is the maximum distance up to which this taking out of water is or the effect of this pumping is there. Okay, so from this particular figure, what we are understanding, see, water table was initially somewhere here. See, somewhere here like this in this level. Now, because of the pumping, what is happening? The water level has decreased. You know, 1 second. Due to pumping, the water level has decreased and became a conical shape. We call it as cone of depression. So till here it has affected. You know? So till this point it has affected. We call it as radius of influence area, capital R. And the radius of this pumping well is nothing but small r, nothing but diameter by 2. That is what we have written here, capital R and small r. This Q stands for yield of the aquifer. Now, what is this H1 and H2, or simply we can put any notations. Nothing but this value is nothing but our higher value H1, sorry, H2, and this value is nothing but our H1. The depression, I mean the remaining portion, this much we got the depression. The remaining portion is H1. H2 is nothing but the thickness of the aquifer. Very important. If this complete thing is the sand layer, this is very, very important point which most of the students used to make mistake. If this complete portion is sand layer, thickness of aquifer means it will be below the water table only. Whenever we are taking the thickness of aquifer, if this was the initial water table location, the complete sand layer is not our aquifer, it is below the water table. Okay, zone of saturation is this. Okay, so this is the equation for unconfined aquifer. Now, suppose if you don't know what is the value of this capital R, radius of influence and all, practically it is difficult to identify. So what theme, another scientist, this is given by Dupitt, and another scientist also contribute whose name is theme. So what theme has told, if you are using some observation wells in between, means something like this, then we can take simply, okay, similar to this previous H1, H2. Here also we are going to get H1, H2 in that piezometers and all, or we can call it as observation well. Then corresponding values we can take as H1, H2. Simply remember higher value minus lower value divided by natural logarithm, higher value or higher horizontal distance divided by lower horizontal distance. Okay, and horizontal distance is from the center of the well. Now that is for unconfined. If it is a confined aquifer, there is a small change in the equation. Instead of H1 square or H2 square minus H1 square, we have S1 minus S2, nothing but the difference between the depressions. Always remember, we have to take the positive value. So no need to confuse which is S1, which is S2. Maybe for in this figure, if I am telling this, I can take it as S1. Initially, it was somewhere here, now water level. Now this depression, I can take it as S2. I can also write S1 minus S2 as H2 minus S1. Okay, same, the difference between that levels. Clear? So equation is having a small change only, that square will get eliminated and S1 minus S2. If it is a confined aquifer, then this B is also coming in the question. 2 also will come. B is nothing but the thickness of the aquifer. Okay. So our question, what is our question? In this question, they have given water table is at 6 meters below. Okay. A drawdown of 4 meters is noticed in the well. Radius of influence zone is given. So which means it is based on this first figure. Okay. They have not given any observation wells and all. Depends on the data, we are going to select the equation, okay, whatever it is. So I'm just taking that same figure here, copy pasted. Right. So what they have given in the question, 45 meter is the total thickness and the water table is 6 meter below. You know, water table, where is it? Yes, water table is 6 meter below the ground level. So can you please comment me what will be the thickness of the aquifer? Can you please comment and let me know what will be the thickness of the aquifer? The complete sand layer is 45 meter. I am getting some wrong answers. I hope that wrong answers came because of this only. Yes, very good. Now the thickness of aquifer is 39 meter. Now what are the other data they have given? The depression in the well is noted as 4 meter. You know, I hope you have already taken down the data. Drawdown is taken as 4 meter. Then radius of influence zone, capital R, is 200 meter. Okay. So this is once again. Yes. So this drawdown is given as 4 meter. And this radius of influence zone, capital R, is given as 200 meter. Yes. So which equation you can use? The first equation we have written here, pi k h1 square minus h2 square divided by capital R divided by small r. Okay. So I'm substituting k and all, let it be there. So it is going to be 39 square minus. Now tell me what will be this h value? What will be that h value? Everyone please comment. How much you are going to take? Yes, very good. Initially it was that 39 height. Depression is 4 meter. So 35 square. Clear it is? Is it clear everyone? Yes. Divided by natural logarithm. Radius of influence zone is given 200 meter. What is radius? Radius of pumping well. How much it is? 80 centimeter. So since I have put 200 here, can I put 40 here? Okay. Any mistake? Is it true? I mean, any mistake? Is it correct? I got again wrong answers. It is because of this thing which I have written just now. Please tell me, is there any mistake in whatever I have written? Very good. This 40 is in centimeter, 200 is in meter. So properly convert that and put it into meters. Okay. That is the next thing students used to make mistake. Properly listen. R value is nothing but the radius. That will be 40 centimeter because they have given 80 as the diameter. Right. Understood? Is it clear? That is the next point. Generally, students used to make mistake in the examination hall due to that tension. Okay. So K value, whether they have given any K value. K value is not given. Now, then what to do? K value is not given. Then what to do? Whether K value is 780? No. They have given that coefficient of transmissibility of the aquifer is 780. What do you mean by this coefficient of transmissibility? It is also called as coefficient of transmissivity. Okay. Yes, very good. Coefficient of transmissibility or coefficient of transmissivity is nothing but K into thickness of the aquifer. Okay. In general, I can simply put it as K into, simply I'm putting K into H only here, where H is the thickness of aquifer. B is nothing but in confined aquifer, we are keeping B. That's why I have kept it as B. This is for confined aquifer. This is for unconfined. Nothing but H and B are same only. Since in confined aquifer, see, I'm just going back to this equation. See, 2 pi Kb. So we can also write this equation as 2 pi into coefficient of transmissivity T into S1 minus S2, like that. Okay, like that also we can write. Understood? So here they have given that K into H, nothing but coefficient of permeability into H value. What is H value here? Yes, very good. I'm already getting the answer. So K into H is already given as 780 meters square per day. H we know that is equal to 39 meter thickness of aquifer. You know, if you are taking H 45, then the entire solution is going to be Wrong. So K value will be equal to 780 meters square per day divided by 39 meter. We'll be getting the K value in meters per day because meter square per day by meter. It is equal to, everyone, please comment how much it is. Thank you. Very good. 20 meter per day. Enough? Now substitute back. If you are substituting it back, how much will be getting? Pi into 20. I'm not calculating what is this value. I'm just keeping as it is, divided by natural logarithm 200 divided by 0.4. See, somewhere you will be seeing the equation 2.303 log. Okay, natural logarithm is equal to ln. Okay, natural logarithm x is equal to 2.303 log x. So somewhere you will see 2.303 log and all. Same equation only, don't confuse. Don't get confused in the examination hall or whenever you are preparing. Now how much you are getting? Please comment. The yield of the aquifer will be equal to, everyone please comment. Yes, 2992 point, can you, 0.6, okay, thank you. What will be the unit? Please tell me the unit also. See, 39, 35, they are in meter square. So meter square, 20 is in meter per day. So meter per day into meter square, nothing but meter cube per day. Natural logarithm, R by R, it is not having any unit. So we are getting in meter cube per day. Unit is also very important. Check in which unit they are asking. In meter cube per day only, then comfortably we got the answer. Sometimes liters per day can be asked. Always remember, if you are taking 1 meter, 1 meter, 1 meter cube, we can save 1000 liters of water. So 1 meter cube is equal to 10 raised to 3 liters. If they are asking in liters, then take multiply with 10 raised to minus 3. Okay, sorry, into 10 raised to 3, that much liters. Okay, if they are asking in liters per day and all. Is it clear, guys? Okay, is it clear? So round off to 1 decimal. So up to you. Okay, you can put 290, 9992.6 or 7. They will give a range because lot of calculations are involved, you know. So they will give a range like 2980.1 or 3100.1, something like that. They may give a range, don't worry. Clear, everyone? Yes, very good. So shall we go to the next question then? Okay. So nothing but related to Muskingum method. I will tell some points in well hydraulics after some time. Okay, depends on the time. I will tell some points also. So can you please do this question? Generally numericals don't used to come in Muskingum method, but I'm giving you a numerical question just to make you confident in Muskingum method. Okay, so just go through the question and understand what is given. Understand what is flood routing method. See, this is very important. Hydrologic channel routing. We are using Muskingum method. We are using Muskingum method for hydrologic channel routing. Hydrologic routing are two types. Hydrologic reservoir routing, hydrologic channel routing. We are using this Muskingum method for hydrologic channel routing. Now what we are actually doing, using the ordinates of an inflow flood hydrograph, we are going to find the ordinates of a outflow flood hydrograph. Generally, what is very important for gate examination is, first thing, whatever we have explained now, Muskingum method is matching with channel routing. Now the second thing, the sum of Muskingum constants. Can you tell me what will be the value of sum of Muskingum constants? There are 3 Muskingum constants. He has given it as C0, C1 and C2. So the sum of Muskingum constants will be always equal to sum of something is equal to 1. Have you seen anything like this before? Very good. Theirs and weightages. Theirs and weightages is equal to 1. Very good. So that also you remember. The next one, sum of Muskingum constants equal to 1. Here they have given C1 and C2. So C1 C2 we have 0.46, C2 we have 0.45. Okay, two coefficients we have, so that we can calculate what is C naught. And now tell me how much is C naught. Add those 0.46 and 0.45, then take -1. Yes, 0.09. Yes. Now how we are going to calculate? Are you getting everyone 0.09? Yes. Okay, using the relationship. Now always listen how we are going to calculate the outflow flood hydrograph ordinates, or we can call it as downstream side flood hydrograph. Here I am putting outflow, or we can also put it as upstream flood hydrograph, downstream flood hydrograph. Okay, the first ordinates of the flood hydrograph will be always same. So the first one will be always base flow. Okay, it is equal to the base flow 40. We'll be having always the first and last ordinates of a flood hydrograph will be equal to base flow, whereas for a DRH and union hydrograph that will be 0. Okay, now how to calculate the second ordinate? We have an equation, but just forget the equation, just use the trick only. Just go in the clockwise direction by multiplying with C naught, multiply with the C naught, multiply with the C1, multiply with the C2. That's it. Just go in the clockwise direction, multiply with the C naught, C1 and C2, put the value here. What is the meaning of this? The outflow value corresponds to time 1. Okay, outflow value at 1 will be equal to 52 into C naught. C naught you substitute 0.9 plus 40 into C1. I'm just putting C1 only here. You can just substitute it. Plus again 40 into C2. Tell me what is the value of outflow flood hydrograph at a time equal to 1? What is that value at a time equal to 1? 41.08. Okay, very good. 41.08 meter cube per second. Are you getting at time equal to 1? Okay, all are getting same? Yes. Now we got one more element here. What is that? 41.08. Now what we can do? The same procedure will repeat. Now like this. Means the first value, how can we calculate the outflow value at t equal to 2 then? Same procedure, correspondingly it is 126 there. So 126 into C naught plus 52 into C1 plus, now we got 41 now into C2. That's it. Henna? So this process will keep on continuing. What they are asking at corresponding to time equal to 2 hours. So here we can stop. Tell me what is the calculated value? Everyone? Yes, very good. Kasturi Das, very good. How much you are getting? 53.746. Very good. 53 point. All are getting the same answer? 53.7. Yes, very good, very good. Krishna, very good. Final answer. So is it an MCQ question or no? Round off to integer. So either you can put 53 or you can put 54. Both are acceptable, no issue. Or they may, sometimes they may give some 52 to 55 like that. But here no much calculations are there, so range also will be less. Very good. All are getting the answer? Yes, that's it. Okay, understand that sum of mass income constant is 1. Like this much level they have not gone till now, but just remember, okay, if they are asking. So this process will keep on increases. And if you are comparing the ordinates, what we are understanding, starting and ending will be same, base flow, and all other ordinates, the inflow hydrograph ordinate will be definitely more than that of outflow hydrograph ordinate. See here we got something 53 point something, no? Yes, just compare with left hand side and right hand side. Inflow flood hydrograph will be always having more ordinates, and if you are calculating everything, the peak also will be higher for inflow hydrograph. Clear? That's it. Now understood everyone? Yes. Now we are going into the irrigation portion. Yes. So take down this question. Under well hydraulics, I will just tell some points at the end regarding some Darcy's law and all. Why I'm not telling it here, you might have already studied that in geotechnical engineering and all. Nothing but Darcy's law, V is equal to K into I and all. If you have time, we'll discuss, otherwise no issue. It's a geotechnical common topic. Okay, so just go through this question. I have just incorporated so many concepts into one question and put it as an MSQ question. Properly take down the data. No need to write the entire question. Just take down the data and we can start solving the question. I will give these questions later. Yes, Dokla definitely will share the PDF. Don't worry. Once the session is completed, the entire syllabus, the entire session PDF we can give. No worry. Okay, don't worry. So no need to take down the entire question, but take down the data and solve it. Yes, have you taken the question? Right? Yes. So in this question, what all data has been given? The specific gravity and void ratio. Okay. The specific gravity is given G 1.35. The void ratio is given as 65%. Permanent wilting point is given 35%. Then effective depth of root zone is 90 centimeter. Consumptive use is given as 10 mm, which is daily consumptive use, so 10 mm per day. So these are the data given. Now just before going into the solution, just remember the water content, the maximum water content the plant can take is field capacity. If the water content is more than field capacity, no use for the plant. It will be there as either gravitational water or hygroscopic water. The field cannot, the plant cannot take it because it will be in the form of hygroscopic water and all. It will be a layer of water around the soil grain, which will not be able to extract by the roots of the plant. This is the maximum water content that the plant can extract, and permanent wilting point is the minimum water content the plant can extract. So that itself can be a one more question. The maximum water level is field capacity, minimum water level is permanent wilting point that the plant can extract. Okay. Now, what is this optimum moisture content which is in between? Because of the evapotranspiration or because of the consumptive use of water by the plants, what will happen? This water content keeps on decreases. So it decreases, and whenever it is reaching permanent wilting point, we have to give the water. If the water level again decreases, which is below permanent wilting point, high chance that your plant will die. And finally, if it is reaching at a water content which is equal to permanent wilting point, absolutely permanently your plant is going to die. And if you are giving the water at a permanent wilting point, then it is okay. Slowly your plant may grow. There is chance that your plant will grow, but the growth will be comparatively in a lesser rate. So what we have to do to get more yield, we will not wait till permanent wilting point. We have to give the water whenever the moisture content is dropped to optimum moisture content. Okay, so these are the fundamentals, and very importantly, what you have to remember, at any point, if I am telling the water content at a particular time is somewhere here. Okay, this is the water content at a particular time. Then if they are asking what is the available moisture, then it is nothing but this water content minus permanent wilting point. Okay, available moisture content is nothing but whatever be the water content minus permanent wilting point. Understood? So if they are asking what is the maximum available moisture, which is nothing but water content is reaching our maximum limit, which is nothing but field capacity minus permanent wilting point. This is the maximum available moisture. which is in percentage or in decimal because it is water content. We can also tell that in terms of depth, means if they are asking what is the maximum available moisture depth, we can convert this decimal value into an equivalent depth value by multiplying with specific gravity and effective depth of root zone. So this is the maximum available moisture depth. There is another term, readily available moisture depth. This is nothing but the other part. This is known as readily available moisture depth. Properly listen. Readily available moisture means field capacity minus optimum moisture content. The below part is known as the available moisture content. In the sense, suppose if the water content is at optimum moisture content, the readily available moisture is above that, the available moisture is below that. Understanding? So available moisture means whatever be the moisture content or water content minus permanent wilting point. Okay, this is fundamental. Now, the first question, the field capacity of the soil they are asking. In this question, they have not given. So how can we calculate the field capacity if they are not giving in the question? There is a very important relationship. The field capacity is equal to porosity divided by specific gravity. Okay, that you should remember. In some question, they will not give that. The field capacity is equal to porosity divided by specific gravity. In geotech, generally we used to take the value G, but here since I have written S, I'm putting S, okay, specific gravity. So just directly substitute, we have the value S, specific gravity 1.35, but we don't have the value of porosity. How can we calculate the value of porosity from void ratio? They have given void ratio in the question, but they have not given the porosity. We have the equation E divided by 1 plus E. Remembering this equation, everyone? Very important in geotechnical engineering. So tell me how much you are getting N value. Everyone please comment how much you are getting N value. N value will be, yes, 0.3939. Okay, thank you. 0.3939, right? So I'm substituting same 3939. Okay, then you will be getting in decimal. Specific gravity is not having any unit. N, either we can put it in decimal or in percentage. If you are putting in decimal, you are going to get field capacity in decimal. We can convert into percentage also. How much will be field capacity then? Yes, 0.3939 divided by 1.35, nothing but 0.2918. 0.2918. I can put it into percentage also if required. Clear? Yes. So go back to the question and check 29.2. Yes. Okay, no? So option A is correct or not? Yes, sir, it is correct. Okay. Now, readily available moisture depth. How can we calculate a readily available moisture depth? How can we calculate a readily available moisture depth? Actual equation is field capacity minus optimum moisture content multiply with field capacity minus optimum moisture content multiply with S into D. This is the actual equation, but they have not given the optimum moisture content in the question, but they have given that the irrigation water is to be applied when the available moisture depth is 35% of the maximum available moisture depth. So what is the meaning? First we have to calculate what is the maximum available moisture depth, from where we are going to calculate our readily available moisture depth. Clear? Now how can we calculate the maximum available moisture depth? I have written here the equation. Maximum available is equal to field capacity. So maximum available moisture depth. I'm simply writing AM to save the time. So FC minus PWP, permanent wilting point, into S into D. Please tell me how much it is, everyone. See, if I want to calculate, just convert into decimal and substitute. Okay. The permanent wilting point is how much? 10%. So 0.1. Convert into depth term. See in which term we have to find the answer finally? In millimeters, no? So the D value given in 90 centimeter. So better you convert here itself 900 mm. Only unit is for D only. So maximum available moisture depth will be how much? 233.037, correct? 233. Is it correct, guys? Maximum available moisture depth? Yes, okay. Now, readily available moisture depth. What they have given? What they have given? Readily available moisture depth is equal to, one second. Yes, readily available moisture depth is equal to, where it is, yes, irrigation water is to be applied, not readily available. Irrigation water is to be applied when the available moisture depth is equal to 35% of the maximum available. What do you mean by available moisture? What do you mean by available moisture? If I am writing like this, percentage of 233 point, please comment, is it correct or is it wrong? Everyone, please comment, is it correct or is it wrong? Everyone. Is it correct? Everyone, please comment. Yes, few are answering wrong, few are right. Very good. Now see, go back. What they are giving? Available moisture depth is 35%. What do you mean by available moisture depth? I told you, available moisture means from here, water content means at optimum moisture content level. If the water content is at optimum moisture, this is nothing but our available moisture. Water content is optimum moisture content minus permanent. Correct? So if the available moisture is 35% of the total value, then what will be this readily available moisture? 65%. Are you understanding? So two ways they can ask, two ways they can give, or three ways they can give. Either they can directly give optimum moisture content, or like this they can give that readily available moisture is 65% of the maximum available moisture depth, or they can give available moisture depth is 35% of the total or maximum available moisture depth. Is it clear? Everyone, this can be the next test. If you are making mistake there, your entire answer is going to be changed. So this is wrong. So that will be 65% of 233.037 mm. How much you are getting? 151.037, no? Yes. Are you getting around 151? Please comment, everyone. What they have given, it is going to be wrong. Correct? Please comment how much it is, this value, 151 point. Is it 151.037? Okay. Is it? Why I am getting different answers? Okay, depends on how accurately you are taking this decimal. I don't have the calci. I forgot. I missed that calculated value. That's why. Okay, whatever, around 151 you are getting. Okay, 151 point something mm. Fine. Okay, 03 something. Okay, whatever, let it be. Now, so second option we got that as wrong. The third one, frequency of irrigation. How to calculate the frequency of irrigation? Frequency of irrigation is equal to readily available moisture depth divided by consumptive use. Okay, so that is nothing but 151.1 whatever you got divided by consumptive use is given as how much? 10 millimeters. Daily consumptive use means 10 mm per day. How much you will be getting? 15.1 something, right? Yes. So 15.1, either I can round it off to 15 or 16. So what we have to take? Or if you are getting something 15.8, for example, will you round it off to 15 or will you round it off to 16? Okay, tell me this example. If I am getting 15.8, for example, will you take 15 or 16? What value we are going to take? Very good. We are going to take 15 only. Okay. Always round off to the lower integer for frequency of irrigation, because if according to this particular example, I mean, whatever I have written here, within 15.8 day, all the water will go, which means we cannot wait till the 16th day. Understanding? So round off to the lower integer 15 days. Understood? What is given in the question? Obviously, that is correct. Okay. Now, if the water application efficiency is 80%, the depth of water to be supplied to the crop. How can we calculate that? How much water actually we have to supply, which is equal to readily available moisture. Water content is keep on decreases. Whenever it is reaching the optimum moisture content, we are going to give water and go back to the, we are making the water level back to the field capacity, which means if we are giving the water actually to be supplied, the water actually to be supplied is equal to the readily available moisture depth. But what they are telling, the application efficiency is 80%, which means if you are giving that water, see, according to my calculation, I have kept 151 point, how much guys? 151.4. Okay, whatever, 151. Okay, according to, simply I'm taking 151.4. Okay, let it be. So if you are giving 151.4, okay, let it be like this, which means 20% of that water will get lost, only 80% will be available for the crop. That is the meaning of application efficiency. Now, if the application efficiency is 80%, then 20% I'm losing. Then should I give more water to the crop or should I give less water to the crop? That only you have to remember. If this value is 151.4 according to my calculation, confusion will come here only, whether we should multiply or whether we should divide. Confusion will come here only, which is correct. That's why I told, if 20% is losing, to finally, if we need 151.4 on the plant, should we give more water or less water? Very good. Obviously, we have to give more water. So in which case we'll be giving more water? Yes, very good. Obviously, we have to divide it with the efficiency. Understanding? Everywhere, whenever you are having efficiency or factor of safety, just think about that. What we actually have to do, mainly in RCC and all, force we are having, factor of safety we are having, we are going to design for higher force. Or no, I mean, whenever we are designing, we are going to design it for higher force, higher load. Then which means we have to multiply with that factor of safety 1.5 and all. If you are checking the settlement, the maximum settlement we are actually limiting. Then if they are giving some factor of safety, we have to multiply with 1.5, 1, whatever, like that. Okay, think about the concept. Then you will be getting whether we have to multiply or divide. Understanding? So how much we are going to get? How much water we have to give? Please everyone comment. Thank you. 189.3 around mm of water we have to give. Then only you will be getting 151.4 mm finally on the plant. Clear? 189 point something approximately according to your calculation. Decimal may change. Going back, see, by mistake, if you are multiplying, you may be getting this answer. That's why I have kept that option. Sorry. So that is going to be wrong. So what are our true statements? A is correct. C is correct. All are getting? All are getting? Is it clear, everyone? Clear? So remember this equation also, field capacity equal to porosity divided by specific gravity. Very important. Now see guys, generally the application efficiency value we will not take in the calculation of frequency. Okay, we will not take. But suppose in the question, see, we have two options. One is this, we will keep the frequency same and we are going to give the water more. We are going to give 189.3 mm of water once we are giving it, but the frequency will remain the same. Or what we can do, we can give only 151.4 mm, but we will rearrange the frequency value. Even before 15 days, we will go and give the value. But practically, which is good, again and again going to the field and giving less water, or we can just wait for more days, and whenever we are giving, we can give more water, which is obviously good. Obviously, giving more water within 15 days, that is good. Now, every time we don't have to go to the field and take the pumping process. So that's what actually we are going to do. If they are giving the application efficiency also, we are not going to consider in the frequency. But in case, that is also a possibility which I told you. In case in the options, okay, in the options you calculated frequency using readily available moisture and consumptive use, you calculated F value. If that answer is there in the question, suppose application efficiency is also given, something like this. So here we calculated and that answer is there in the question, then we will select as it is. Okay. In case only in multiple choice question I am telling, if it is numerical answer type, do like this. In case in multiple choice question, this answer is not there, for example. And if you are using this application efficiency, you will get something less, some 12 days or 11 days like that. That option is available in the question. Okay, in the option. And this value is not available in the option. Then we can go for this option. Are you understanding? Because we don't have any other options available. Okay. So by default, we will not take the application efficiency because practically we are doing like that. We'll increase the depth of application, the depth of water that we are applying by keeping the frequency as same. Okay. But in MCQ type of question, in case the data or in case the value is not available in the option, and if you are using the application efficiency in the calculation and that value is available, then we'll go for that. Understood? Because that is also a possibility for us according to the given option. Is it clear? Everyone? If it is numerical answer type, then always go for the conventional method only. Don't take the application efficiency. Is it clear, guys? Everyone? Yes, very good. Now going into the next concept, underwater requirement of crops. So the first concept, we have discussed so many concepts in that first question. Then the next very important thing is the canal design discharge or crop seasons and all. So what we need to remember, first you can just, okay, let the question be there. I'm just telling some points. Whenever we are designing a canal, we have to check in Kharif season how much quantity of water we should have, and in Rabi season how much quantity of water we should have. Okay, we have two crop seasons, Rabi season as well as Kharif season. No need to by heart this month and all. That is just for your understanding. We have different types of Kharif crops. We have different types of Rabi crops. You can simply Google it. Lot of examples you will be getting. I have just selected famous examples which are repeatedly asking in exams. Okay, even they are asking rice, maize, cotton only from Kharif crops, wheat, tobacco, gram in Rabi crop. I have just given some more examples. You can just Google it and you can just find more examples also. And some crops we will cultivate in both Kharif season and Rabi season. We call it as perennial crop. Perennial crop. Some fruits are examples of perennial crops. Some trees are examples of perennial crops. But in all the competitive exams, the most important and famous example is sugarcane. So they may be giving you sugarcane only because they cannot give you different names of trees and all. Na? That's why. Okay, so sugarcane either we can cultivate in Kharif season or in Rabi season. So in a Rabi season on the field, we will be having this Kharif crops, and along with that we can have the sugarcane. Similarly, in a Rabi season, we will not be having Kharif crops in the Rabi season. We will be having only Rabi crops, but along with that we can have this perennial crop or sugarcane also. Understanding? So we have to check what is the discharge required in Kharif season, and we have to find what is the discharge required in Rabi season. Which of these two values are more or maximum? That maximum value will be our minimum discharge value. Similar to we have discussed the length of transition curve in transportation engineering, or in RCC you will study maximum spacing is equal to minimum of some value, like that. So similarly, we will discuss, we will check what is the discharge required in Kharif season. We will check what is the discharge required in Rabi season. Whichever is maximum, that maximum value will be our minimum design discharge in the canal. Okay. Now go back to the question and take the data, properly check the data. They have given intensity of irrigation, delta and base period, or of 4 different crops which are cultivating. So properly remember the examples so that we will be able to take the proper combinations. So take down the data fast. I'm giving some time for taking the data. How can we calculate the discharge value? I hope you know the concept of duty. Meanwhile, you can take the data also. The duty of water is nothing but the area which can be irrigated using 1 meter cube per second discharge if you are giving throughout 1 year, throughout the discharge 1 meter cube per second throughout the base period. Okay, so 8.64, the duty of water is equal to 8.64 B divided by delta, where B should be in days, delta should be in meter, so that we will be getting the duty of water in hectare per cubic. What is the meaning of this? Cubic means meter cube per second. If you are giving 1 cubic water or 1 meter cube per second water throughout this base period B, how much hectares of area you can irrigate? That is the meaning of duty. Okay, so what I can write? Duty is nothing but area divided by cubic is discharge. So we have to calculate this discharge value, which means how can we calculate this discharge? Nothing but area divided by duty. So we can calculate area by duty of rice, we can calculate area by duty of wheat, and so on. Then which all are there in the Rabi season, we have to group together. Which all will be there in the Rabi season, we have to group together. Then we have to check. Understood? Is it clear till here? Yes. Have you taken down the data? Can I just change the screen? Can I change the screen? Yes, thank you. Now see? Okay, you can see the data there also. What do you mean by this intensity of irrigation? It is not like our intensity of rainfall and all. Intensity of irrigation means how much percentage of culturable command area is irrigated. Means if we have the culturable command area of somewhat 100 hectare. And if I am cultivating rice for 50 hectares of area, intensity means 50%. Understood? Out of the total culturable command area, how much is the area under that particular crop is the intensity of irrigation. They have given that 50 kilometers square is the intensity, 50 kilometers square is the culturable command area. And for rice, I have just written all the data here. From here, we can just directly calculate what is the discharge required for rice, which is nothing but area by duty. Now see guys, duty value, if you are substituting 8.6 for 145 days, I told you delta should be in meters. So 1.2, in which unit you are going to get? We are going to get in hectare cubic. So discharge cubic per second. Area should be in hectares. So they have given that it is 50 kilometers square. How to convert 1 kilometer square is equal to 100 hectare. So 50 into 100 hectare. Understood? So we have to convert that area into hectares. Then only we are going to get hectare, and hectare will get cancelled. We'll be getting in cubic. Okay, please calculate and tell me how much discharge you are getting for rice. Can you please comment how much discharge you are getting for rice? 1 second, let me compare with my answer also. Are you getting 1.43? Okay, very good. I'm getting the final answer also. Yes, your answers are correct. 1.4367, enough? Thank you. 1.4367 cubic. So similarly, you can calculate for cotton also. Sorry. This is not 5,000. This will be what? Intensity is 30%. So 0.3 into. Answer is correct, but I have written it here wrong. Okay, thank you. So similarly, Q for cotton, we can calculate. Cotton is equal to 0.15 into 5,000 hectare, 8.64 into 180 divided by 0.45. Okay, properly note down the units. For cotton, you will be getting 0.217. Am I right? For cotton, it is 0.217. Yes. Cubic. Please compare your answer. 274 or 217. Please compare your answer. 217 or 274. Please tell me. Similarly, here we will be getting for wheat, we are getting 0.58 something. Am I right? Approximately. Yes. Then for sugarcane, we'll be getting 0.3743. Enough? Okay. Thank you. Q is equal to 3743. All are getting the same answer. Take your time and do. No issue. Yes. Very good. Now see which all crops are there. Examples of Kharif. Rice is Kharif. Cotton is also Kharif. But wheat is Rabi, whereas sugarcane will be there in both season. So what we have to check? The required discharge will be whichever is maximum out of those two, which means rice plus cotton. Rice will be 1.4367, cotton will be 0.217, sugarcane will be 0.3743. So I'm writing only the sum 2.028. Are you getting the same? Are you getting the same in Kharif season? Sum of rice, cotton and sugarcane. And in the Rabi season, we will be having wheat plus sugarcane. Nothing but 0.5864 plus 0.3743. We will be getting 0.9607. Are you getting the same? Approximately. Can you please comment, everyone? Approximately 0.96. Okay, 95. Okay, depends on your accuracy in calculation. Right. So which is our answer? Our answer will be 2.028 cubic. But this much discharge if you are giving, we have to make sure that this is finally reaching in your field. So that we have to check. They told that the canal discharge is having some loss, which is 20%. 20% loss means conveyance efficiency will be 80%, and also they have given a time factor of 0.9. So whenever they are giving time factor or conveyance efficiency and all, what we need to do, if we are having 2.028 cubic in the canal, if you are having some loss, we have already discussed that concept. If you want to give more water, then obviously we have to divide with it. And time factor is also given, that also we have to divide. What is this time factor actually? Maybe you are planning to give water for 10 days. Okay. And maybe for canal lining or some repair work, you are actually planning for 9 days supply of water only. Then what you have to do? Daily you have to give more water. Time factor means the actual period of watering period that will come in the denominator, what actually we have given. So 1 day, if it is not operating, means 9 days by 10 days of total, which means 0.9, like that. Clear what is time factor? So if they are giving that in the question, Definitely means if you are giving the water for the throughout days, then 0.08 by 0.8 will be sufficient. But they have given that that many days we are not giving the water, only 90% or 0.9. Then how much finally you are going to get? Yes, very good. 2.816. Yes, very good. Understood? So this much will be your final answer. Is it clear, guys? Is it clear? Is it an MCQ or no? Round off to 1 decimal. So either you can put 2.8. Okay, they may give a range, don't worry, because some calculations are there. Is it clear, guys? Everyone? Is it clear? Yes, since all are giving the answer. Yes, okay, very good, thank you. Okay, so one more question we can discuss regarding gravity down. So just go through the question and understand what is given. Just understand the question. Properly go through the question and understand what is given. Then I will explain. Yes. Okay. The net horizontal hydrostatic force. They are asking what is the meaning of hydrostatic force? Nothing but the force due to the water pressure. Okay. It is storing some water on the upstream side. Sometimes they will give water on the downstream side also. If any problem with the font size, upstream side we have 70 meters of water. Downstream side we have 5 meters of water. So force due to this stored water is known as hydrostatic force. Okay. So how can we calculate that? I have just given a figure here. This is how the force due to water pressure will act. Okay. The stress distribution or the water force or water stress or hydrostatic stress distribution will be like this. So the net force will be acting somewhere here at a height of h/3 from the center. Similarly, here also h/3 from the center. On the downstream side, we will be having a vertical force also, which is equal to the weight of the water in that portion. Okay. So this much portion we have water. So weight of this weight of this water portion will be the vertical force. The horizontal force will be similar to the upstream side. And what is that horizontal force? Here, if we are having F1, that is equal to half gamma W h square, nothing but area of this triangle. Half into gamma W into h is the base into h. Here also we will be having, if I am putting that is F2, half into gamma W into h square. Right? So we can easily calculate. Please calculate and tell me how much it will be. Whether they have given the value of gamma W. No. If they are not giving the gamma W value, sometimes they will give 10 kilonewton per meter, a meter cube. Here we want to calculate in kilonewton terms. Okay, kilonewton per meter. So take the value of gamma in kilonewton per meter cube, which is 9.81 kilonewton per meter cube. Sometimes they will give in the question to take it as 10 and all. Multiply with 70 square. Please tell me how much it is. Similarly, here also we can calculate 9.81 into 5 square. We are going to get something in kilonewton per meter. That meter stands for meter length. We are seeing the cross section per meter length, how much it is. Okay. So please tell me how much is your F1. F1, are you getting F1 is equal to, sorry, I have not calculated F1 separately. Okay. Now see, F1 is in this direction, F2 is in this direction. So totally, what will be your net or finally what will be your horizontal force? The horizontal force will be equal to, is it F1 plus F2 or is it F1 minus F2? What I have to take? Should I take F1 plus F2 or F1 minus F2? Yes, very good. I am already getting the answer. What is the value? Yes, very good. F1 minus F2 because it is in the opposite direction. So how much you are getting? F1 minus F2? Are you getting 23911? Are you getting 23911 point something? If they are not giving the gamma W value, try to take it as 9.81 only. Don't take it as 10. Maybe they will give that also in the range. If you are taking 10, you may get something 2 for something. Maybe they will give, but better don't take risk. Okay. Are you getting this answer, everyone? Please comment. 23911. Yes, very good. Now coming to the uplift force. So what they are asking in the second part, round off to integer. So you can just round off to 23910 or 911 or 912, whatever. Okay, they will give. Don't worry, they will give a range. Now see, if they are giving as 10, then always take it as 10 only. Okay, maybe they will give properly that in the range also. And if a drainage gallery is provided at 35 meter from the toe of the dam. So what is toe? For a dam, this is nothing but the heel. Remember, this is heel, that height portion, heel of a chapel, height, and this is toe. Remember that. Now what is given? 35 meter from the toe. Means somewhere here it is. What is the total width? They have given that total width is 45. So one drainage gallery we are giving here. So this is 35 meter. Then the left hand side, this is 10 meter. So if you are giving like this, what is the reduction in the uplift force on the dam? Okay. So before going into the calculation, just listen here. If we have capital H meters water on the upstream side, if you have small h depth of water on the downstream side, this is how the uplift pressure diagram will be. Gamma W into capital H, gamma W into small h. Actually speaking, we will multiply with an uplift coefficient C here and here also. Most of the time we will take it as a linear variation by assuming C is equal to 1. Sometimes they will give in the question uplift is neglected, then we will not take C equal to 0 then if uplift is neglected, or if they are giving there is a linear variation from the full hydrostatic head and all, we are going to take a linear variation. So either linear or 0, that's it. Okay. Now in the second case, the same dam, if I am introducing a drainage gallery here, a drainage gallery is actually a hollow portion. The width will be very less compared to the width of the dam. If we are applying a drainage gallery here, what will happen? So this is what we actually have as of now. The uplift pressure diagram is like this. Area of this uplift pressure diagram is nothing but our uplift force. Now due to the presence of this drainage gallery, what will happen? The uplift force will decrease and will take a shape like this. Means this much reduction will happen. See this portion, this much reduction will happen. Understanding? So how to calculate this area of this diagram? How to calculate area of this diagram? And now see, if there is no water on the downstream side, then what will happen? Then the diagram will be like a triangle because gamma W into small h is 0. Okay. If on the downstream side also we have water, then what will happen? We are going to get, sorry, 1 second. So we are going to get, see a figure like this. What we are actually going to get? 2 trapezoid we will be getting. One trapezoid here, see like this, and another trapezoid here like this. So we can calculate the area. So we have to calculate this first case, we have to calculate the second case, we have to take the difference. Now very important, here we have C into gamma W into capital H. By default we are taking 1, gamma W into small h. Now what will be this ordinate? Nothing but gamma W into, properly listen, small h plus capital H minus small h divided by 3. So this will be the ordinate of that portion corresponding to the drainage gallery. If you are expanding this bracket and all, finally we are going to get 2 by 3 into gamma W into small h plus 1/3 of gamma W into capital H. Means that higher value into 1/3 plus that lower value into 2/3. Okay, if you are expanding, you will be getting that as the answer. Okay, so depends on the location, we are going to give the drainage gallery. Why we are giving the drainage gallery? To reduce the uplift force. Uplift force is something which will decrease the stability of the dam. Okay, so our drainage gallery is nothing but a hollow portion. Actually, it's like our room. Okay, it's a hollow portion, but it will not be too big. It is just for taking the water out. Some seepage water may be there. It's like a tunnel, as simple as that. It's like a tunnel in a very big dam. Okay, we will not give too much space because it will reduce the stability. Okay, because the weight of the dam is getting reduced, no? Whenever we are making a tunnel, that's it. So just calculate the first one, just calculate the second one, then take the difference. Everyone? Properly calculate it and please tell me how much you are getting. How much you are getting for the first one? I'm just waiting for your reply. So the left hand side will be 9.81 into 70, you know? So this value will be 9.81 into 70. This value will be 9.81 into 5. So what will be the uplift force? Area of the uplift pressure diagram. 9.81 into 70. See, A plus B by 2. 9.1 into 5. A plus B by 2 into, what is that base width? 45 meter. So you can calculate that. How much you are getting? Can you tell me what is that uplift force totally? Uplift force for this first place. Are you getting it as 16554? Are you getting 16554 point? According to my calculation, I was getting like this. I just want to confirm. Are you getting like this? Okay, thank you. Properly look at the units and all. Okay, 1655.4. Is it clear? Yes, very good. Pragai, properly, yes. Okay, very good, very good. Understood? Now keep it there. Now what about the second one? Here also we are going to get 9.81 into 70. Here we are getting 9.81 into 5. You just calculate. And once you are doing this calculation, that ordinate will become, how much you are getting that ordinate? Are you getting 260.1? Are you getting 260.1, everyone? Please comment so that I can confirm my answer is correct. Yes, okay, thank you. So how can we calculate that uplift force? Area of that pressure diagram, you know? So this value 9.81 into 70 will be how much, guys? 686 point something, no? 686.7. Yes. So the other portion will be 49.05. Correct? So the first part, I can just split it into two parts. The first part will be 686.7 trapezoid, okay, A plus B by 2. 261.1 divided by 2 into what is the corresponding width? That is 10 meter, you know, plus then the next area. First of all, I am taking the area of this, then this area. What will be that? Similarly, 261.1 plus 49.05 divided by 2, A plus B by 2 into 35. This is why you should know what is a heel and what is a toe and all. Enough? So tell me how much you are getting the uplift, reduced uplift. Tell me the total value. No need to tell separately. Separately, if you are calculating some 4741, then 5436 something, then 101.77 something you are getting now. Yes, thank you. 101.77 point. Please comment your answer also so that I can check whether my answer is correct or not. 101.7. Okay, thank you. Correct now? always this value will be less than the first case. Okay, if they are asking such a question, if you are getting more, which means either you made mistake in the first calculation or second calculation. Okay, which means how much is the reduction? First value minus second value, how much is the reduction? Very good, 6376.5. Very good, very good. Few students are commented already. Understanding? Clear, everyone? Is it clear? And you can see one thing in this question. I have taken water on the downstream side also. Water, if the water is 0 on the downstream side, then the equation will become like a triangle. Okay, in the last year GATE score booster session video, I have taken such a question where the downstream side water level is 0. You can just watch that also and practice the question. Is it clear, guys? All are getting 6376.5, right? Yes, very good. Okay, so shall we go to one more question and finish the session? Is it clear, everyone? Shall we go to the last question and finish the session then? Everyone please comment, are you getting the answer or not? Yes, very good. Very good, very good. Now I am giving you the last question of our session. Take this. We have more concepts actually like Bly's theory and all, but it is very unimportant. Within just 30 seconds, I can just show you some equations and all, no issue. Yes, very good. Now see, before going into the question, I'm just showing you some equation. If you want, you can take some screenshot or later I can give you a PDF, don't worry. The minimum base width of an elementary profile. Elementary profile is very important. What do you mean by elementary profile? A gravity dam is in the shape of a right-angled triangle. So whenever we are telling right-angled triangle, so many things are obviously clear. This angle will be 90 degree and this upstream face will be vertical and the water level will be equal to that of the height of the dam. Okay, these things you should remember. Elementary profile of a gravity dam can be asked for MSQ type of question also. Shape is right angled triangle, so that upstream face of the dam will be exactly vertical. Top width of the dam will be 0. The water level on the upstream side is completely full, means free board is 0. Downstream side there is no water. Understood? So these are the points you should remember for an elementary profile. And these are the equations to calculate the elementary profile base width, minimum base width. As we have already said, if they are asking some minimum value and if we have more than one equation, we are going to take maximum of those value, which will be our minimum value. Properly you have to study separately. For no sliding condition, what is the equation? For no tension condition, what is the equation? Recently, when they asked the question, directly they asked for no sliding condition, what is the value? Then we'll stop the calculation here. But if they are not asking any condition, then both condition we have to calculate and take the maximum value. If they are asking you only particularly one condition, then don't calculate both and take the maximum. Take the value corresponding to that particular condition only. Clear? Now go back to the question and take the data, direct substitution within 30 seconds, answer is ready. Now tell me what is the answer? Very easy, direct substitution. It's not a complex question and all. I just want to let you know that this particular topic is important. That's it. Yes, according to the first data, capital H is given directly 15 meter. And how can we take the G value? Specific weight is given. Specific weight is given 25 kilonewton per meter cube. Specific gravity is nothing but, or G or S, whatever, G is equal to, that is equal to gamma W. Okay, which is nothing but 9.81 kilonewton per meter cube. Whether they have given anything? No. In case if they are giving that it is assumed to 10 kilonewton per meter cube, we can take 10 or take 9.81. So you may be getting, okay, whatever it is, I'm not calculating it and separately writing. So if I am substituting it here itself, 15 divided by root of 25 divided by 9.81. See how much I have to take the C value. Properly check what they are giving. The full uplift force, linear variation, full hydrostatic head at the heel and all. What is the meaning of this? Whatever we have drawn, see like this. I told you for an elementary profile, downstream side water is 0. So here it will be 0. Here we will be having full hydrostatic head gamma W into H linear variation, which means C is equal to 1. There are two cases. Either they will give uplift is neglected. If they are giving uplift is neglected, which means we will take as 0. If they are giving that it is linear variation, then we will take C equal to 1. So here, since they have given the corresponding sentence, we can put C value is equal to 1. Then you will be getting some answer. You please comment how much you are getting for the first one. This is 15 divided by mu value, coefficient of friction. They will be giving in the question, given as 0.4. 25 divided by 9.81. See, properly check how much they are giving the gamma W value. Sometimes if they are giving 10, take as it is, because correspondingly they can give you the range also. So yeah, thank you. 12.05 and 24.2. So this is 24.2 meters. This is 12.05 meters. Okay, thank you. Now what will be our minimum base width? The minimum base width will be equal to the maximum of these two values, 0.5, 24.2. That is nothing but 24.2 meter. As simple as that. Understood? What they asked, round off to 1 decimal. Okay, then you can put 24.2. Only thing is, properly have to check the C value. If they are giving uplift is neglected, or if they are giving negligible uplift, something like that, if they are giving, take it as 0. Is it clear, guys? Okay. Understood? Yes. So that's it. We are finishing it off here, and which I told you one some extra point is nothing but yield from an open well. If they are asking, we can simply put yield is equal to C into A into H. We are not going to do any question. Simply, okay, this is not that much important. Specific capacity multiply with surface area. Surface area is nothing but pi by 4 into d square. D is the diameter of the well. They will give some depression head. So this is how we go to calculate the yield of an open well. One thing you can remember, recuperation test is used to calculate the specific capacity. Not that much important, but Darcy's law you should remember. This is important, but you might have already studied this in geotechnical engineering. Seepage velocity is nothing but the design velocity K into I divided by the porosity value. And where is the application? If they are giving some, if they are asking what is the distance traveled by a tracer from one location to another location, we can calculate the time of travel using distance divided by velocity, because velocity is equal to distance by time. But whenever we are substituting this velocity, what you have to take? Distance divided by seepage velocity. Okay, this is the application, which is nothing but distance divided by whatever is the value of Darcy's, whatever is the discharge velocity calculated by Darcy's law divided by porosity. Okay, so this is the application of Darcy's law that also you have to keep in mind. Whereas K is the coefficient of permeability. I is nothing but the hydraulic gradient. Okay, head loss divided by total length. Hope you know these things. If you don't know, no problem. You can just comment in the comment section. We can discuss that in the geotechnical session. We will meet again for the geotechnical score booster session also. So I hope you understood majority of the important portions from irrigation and hydrology. If you have any doubt, no worries. Once this video is getting uploaded in the channel, you can just ask in the comment section. I will be definitely replying you there. Right. So that's it. We are finishing the irrigation and hydrology gate booster session, score booster session. And now we will meet with the transportation part 3. Just visit the channel, subscribe the channel, and click on the bell icon. You will be getting the notification for the part 3. Most probably it will be on the next day, tomorrow, maybe 12 o'clock. You just go to the page and go to the YouTube channel and check it, okay? And that's it. We are finishing off with irrigation and hydrology. So thank you everyone. Thanks for joining. Hope you enjoyed the session, and thanks for your cooperation also. So shall we wind up? Yes. So thank you. Good day for everyone. Prepare well and don't skip irrigation and hydrology, since the weightage is only 5 mark compared to geotech, environmental and all. It is half, but it is an easily scoring subject. 5 mark is actually around 20% of your cutoff mark, so very easily we can score those marks. So that's it. That are the very important topics that we have discussed. 1 second before just winding off, you can just take a screenshot of this page also, which is nothing but Lacey's regime channel equations. Not that much important, but in few years they have asked some questions which is directly based on the equation. Okay, that's why I have written every equation on the screen. I have written what is each term also. So whenever you are checking the previous gate questions, you will see the questions based on this direct substitution, as simple as that. Okay. So that's it. Maybe tomorrow you are going to get the environmental session. That may be at 2:30 p.m. I guess. And the transportation session may be at 12 o'clock. So you just go to the channel. You will be getting the link and all. You will be getting the notification there. So if anyone has not subscribed the channel, please do it and click on the bell icon also, so that you will be getting that notification whenever a live session is coming. Okay. Now onwards, how many live sessions will come? So many videos will come. So keep in touch. Whenever you have, whenever you are getting any doubt, please comment below the video. I will be definitely monitoring it on daily basis, and I will be commenting there, and I will be clearing your doubt. Okay. Not only me, the entire team. Okay. So thanks for joining. Thanks for your cooperation. So shall we wind up? Yes. So thanks for joining everyone once again. Thank you so much. Prepare well. All the best for your exam. Have a good day.